So, okay, good afternoon. So we will end this one course week by talking about, as I said, the Anthropocene. And in fact, this title here is a little bit, well, it will be a bit different, but in fact, I am a geologist, and I just want to give you my point of view about these Anthropocene problems. Well, you have seen that Earth is triggered by a lot of different kind of mechanisms, very complex processes, which include a lot of parameters, and sometimes it's quite complicated. But anyway, now this afternoon, I just want to say a few words about the possible sixth extinction. And we have learned quite a lot from the past mass extinction. And the question is maybe we can apply what we learn from the past to the present or to the future. And so here, what I want to do is just now jump into the Paleocene, and here you have a huge change that you can see. And this huge change is linked to greenhouse gas, to mainly CO2. And I think that you have learned during this week that CO2 was really a greenhouse gas, and leading to some warming. And actually, the warming is quite, let's say, dramatic. So we go back to that. Remember, we have seen that at the very, very beginning. And again, this is in French, but I think you can understand that. You have some so things triggering cause interaction of the process leading to global event are, as I said at the very, very beginning, cosmic here, coming from, for example, solar radiation, cosmic radiation, orbital cycle, Milankovitch parameter, asteroids, cosmic dust, impact. Or these things can be also internal to the Earth, and mainly, for example, I don't want to go in detail again, but mainly, for example, the magmatism, the volcanism, the modification of the, let's say, paleomagnetic field. And I think yesterday somebody, I don't remember who, were asking about the role of the change in polarity in during more or less the life evolution. It's not very clear, but there is one thing which is quite sure. I don't remember who asked this, but somebody here. And it's quite clear that during mass extinction, you have a lot of volcanic activity. And generally, when you have a lot of volcanic activity, I'm not really a specialist, but you can ask to Syed, because he is what I call a paleo magician. Not really, this is because, you know, it's a little bit magic, and just to divide the Earth history in black and white, a time period, reverse, normal, reverse, normal. But in the details, sometimes it's a bit more complicated, because sometimes it's not so easy to know exactly when it's white and when it's black. Sometimes it's gray. It's a little bit like in science. But anyway, it was for sure that during this kind of high volcanic activity, there is from time to time an increase in the frequency of the change of the polarity. And this increased change of polarity may lead, may make more or less the global paleomagnetic envelope of the Earth, which are protecting us from cosmic radiation, dust, and so on. UV, for example, radiation is weaker and can accelerate. If you have more radiation, this can accelerate the rate of the mutation of chromosomic mutation to the species, and create some problem, malformation, and things like that, and accelerate the evolution or the extinction. But it's not very clear. There is not really a really strong link. But this is just to answer to the question that somebody was asking yesterday. Yes, the magnetic field is very important, can influence the genetic of the animals, and clearly is also protecting us from a lot of things. Without a paleomagnetic field, I'm not sure that life would have appeared on Earth. Okay, and here, if I just go back to that, now, well, this is the Earth, okay, and this is more or less all the parameters which were more or less acting during all the history of life that I just show you in these 5 days. And now we have to add another parameter. This is the human activity. And human activity here, I put it in the center because human activity is clearly influencing our biosphere, climate, and sea level, because, well, if the ice cap are more or less melting due to the increasing warming, due to the emission of the greenhouse gas that we are emitting day and night, you will have a sea level rise, for example, and this will change a lot of things too, okay? So now, compared to the natural system that I show you, you have to add this human activity. And clearly, this will change a lot of things. And the Earth has known, as you can see here, this 5 mass extinction. And maybe we have to add one. This is the Anthropocene one. And if we have a mass extinction, it would mean that this is the end of the Anthropocene. That's why I think that maybe the Anthropocene, the last period, which has been defined by the fact that the man is, the humanity, is influencing so much the Earth that you will have a huge change, may lead to an extinction. Evidently, somebody will survive. And for example, I just remember that you have 12 million of insect species, and I'm sure that they may survive. So that's why maybe the next period will be the Insecticene and not the Anthropocene. This is just my philosophical point of view. But just to tell you that in fact this Anthropocene, in terms, if you are seeing more as a 4.5 billions year, this is the age of the Earth, it's almost nothing. And the human, through the history of life, are almost nothing. So do we really have to create a special stage for a species which maybe will not last than in the future, a few thousand years? This is a good question. Okay, but let's go back to the definition. Paul Crutzen is really a clever guy. He shares the Nobel Prize for chemistry in '95. And why? Because this was the first to observe the depletion of the atmospheric ozone layer, which were more or less starting to be destroyed by the emanation of a lot of fluorine gas coming from human activity, which you have in several products. And I remember that we limited this product, and by now the ozone layer is in a lot better shape, which is quite good, because at least it means that humans, when they want, they can change something. You can change something, which is quite interesting. But what he said, that the damage was so extensive, the damage to the biosphere caused by human activity since industrial transition was so extensive that the present interglacial era, named the Holocene, we are living in the Holocene, definitely. Holos means in Greek same age, if you want. We are living in this same age. Should be renamed as an Anthropocene. And this proposal has been taken by many climate specialists. And the first to really take this in serious were people from England, with the Zalakiewicz group, and they form a group in the International Commission of Stratigraphy in order to discuss that. That's a little bit what I want to discuss now. Do we have really officially to introduce this stage? Okay, so something which is really sure that we are talking everywhere about this recent global environmental change and about the Anthropocene. The Economist is talking about that. There is several books. There is a journal. We had before the Holocene, but now we have a journal, Elizabeth journal, named the Anthropocene. There is many papers in this kind of journals dealing with the Anthropocene. And this is good. And this is very good for two reasons. And I think that's why I think the discussion about the Anthropocene is very good, because it makes the people think. It makes people to be aware that we have a big problem, actually. That we are transforming so fastly the Earth that maybe the Earth will not survive. At least the human will not survive. And I think this is a principal quality of the discussion of the Anthropocene. And here the problem, it's not really a scientific discussion, it's a philosophical discussion, and there's something to do with human, not really with the science. So there is a lot of politics here, clearly. But I think that politics is really necessary. Because actually, I think that the rate of contamination, for example, in India, in New Delhi, is something which is really puzzling. Because people are dying when you have really this kind of condition of contamination. And we have really to move from that state to another one. Okay, so it's for sure, it's very clear that due to the greenhouse gas emission everywhere in the world, we know that since the beginning of the Industrial Revolution, that's to say 17 and 50 years ago, the year 1750 more or less, the burning of fossil fuels and extensive clearing of native forests has contributed to 40% increase in atmospheric CO2. That's to say from 280 to more than 400. Actually, it's 415 in 2019. And we know now that this is completely proved, apart from Trump and some political, and I'm sure that you have also some political in India who doesn't believe in this warming. You have this in France, you have this everywhere, unfortunately. But this is really true. We have a temperature increase, actually of 2.4, 2.8, and this is leading by now to a sea level rise, okay? But if we go on, it will be a lot more that this 2, 3 increase in temperature of this less 1 meter sea level rise. Okay, so, and this is due to the mainly greenhouse gas, okay. So that's why people were trying to say, okay, now it's time to fix a new period. This is the Anthropocene, this is a human period. And in this human period, everything is changed by the human, okay? Meaning that you have plastic, you have everything is changing everywhere. So we have to more or less put some age for that. And there is some key question. And this has been identified by the International Commission of Stratigraphy. And these key questions are quite important because there is a conflict here between the stratigrapher, as me, for example, who wants really a clear definition, not something which can be really preserved, not something which can be really diachronous through the Earth. So we really need a clear definition. And I am really not sure that there is a clear definition which may last for enough time in order to define an international stage. That's why I can tell you straight away, I am in favor of an informal use of the Anthropocene, meaning that I don't want to put a limit. I just say, okay, well, since many years. We are in the Anthropocene, but I don't want to put an official limit, because I call this anthropocentrism, because I think that the story of Earth is very, very long, and I think the human have not really the right to put a boundary like that, at least till now, especially if the stage will be so short. So here there is a key question. First of all, do we have a well-documented and significant stratigraphic record to the Anthropocene on which we can base a recognition worldwide and define a boundary with underlying Holocene strata? Okay, this is a really question. Do we have really a stratigraphic boundary? As I show you several stratigraphic boundaries this week, do we have that? Should the base of the Anthropocene be defined using a physical reference section, a golden spike, as I show you for the KT boundary, for the PETM, or should be beginning to define in terms of numerical date? That's to say, okay, we decide, for example, that since 1950, there is a so huge acceleration in the human use of everything in the industry. I will show you an example afterwards. That, in fact, we just say, okay, it's a number. That the Anthropocene is starting in 1950, for example, and we stay with that number, whatever is more or less a boundary. Okay, this could be a solution, but the stratigraphers don't want that because they are geologists and don't want to see a boundary. Okay. Is Anthropocene is a unit of history, of human history? And this is a big question. And here, this is where I am introducing the term anthropocentrism. I think humans are part of the Earth history, well, Earth history is not part of the human history. This is something a lot bigger, okay? A lot larger, a lot longer. And what is the usefulness of the Anthropocene as a time unit material to be visualized by geoscientists and the other interested communities? It has been really useful to define an Anthropocene. You will have to answer to that question in 1 hour. And what is the relative values of formalizing the Anthropocene chronostratigraphic geochronological unit as opposed to leaving that as informal? It's exactly what I said. To me, I don't think that's so necessary to have a very official definition. Okay, so I guess that you know that movie. In fact, to look for a GSSP, this is very difficult. And this is not so easy. This is like if you are in search of the Graal to find the best GSSP. I can tell you, for example, that the discussion about the location of the GSSP for the Paleocene-Eocene terminal, the Paleocene-Eocene boundary, which now is officially accepted as starting at the negative shift of the DC13 that we have seen, which is a really good idea because you see it everywhere in the world, on continental paleosols, on marine sediments, on deep marine sediments, has been more or less decided after discussion and discussion. So clearly it's not so easy. And here these are more or less the rules that are imposed by more or less the International Commission of Stratigraphy. I say that if you want really formally a GSSP, for a formal definition, you need a principal correlation event, a marker. So we have seen several markers. We have seen stabilized tops, for example, for the PETM. We have seen the iridium plus the disappearance of plankton foraminifera for the KT boundary. We have seen a lot of things like that. You can also use micropaleontological marker like the appearance or disappearance of a conodont, like they did for the Permian Triassic. So there is a lot of way to do it, but we need to find this. But this marker must be valid not only for 1 or 10,000 years, but millions of years, because we are doing that for the future. And after that, we have to find some other markers in order to replace maybe the main one. It could be, for example, for KT boundary is the best example. You have the rhythm anomaly, you have the delta C13 shift, the crash in productivity, the change in planktic foraminifal fauna, all these things occurring more or less, at least geologically speaking, at the same time. And here you need more or less that these markers must be globally correlative. It's quite important, it's not so easy. And here this is the main problem for the Anthropocene. You must find a complete continuous sedimentation with adequate thickness above and below the marker. And here we have a big problem. Below, it's not a problem. You can have any kind of sediments, but above, if you put your Anthropocene boundary in the years 50, for example, well, in a lake, it's possible, because normally in a lake, in a Swiss lake, I will give you an example. Since the 50, you accumulate something like maybe 20, 40 centimeters of sediments. It's not so much, but there is something. But it's not a huge thickness, clearly. This is not 1,000 meters that we will accumulate above the KT boundary, for example. And this is a big problem. After, okay, the exact location and so on, accessibility is very problematic sometimes, but I am especially talking about the political accessibility. There is a lot of places where you have GSSP, like the Cretaceous Tertiary one in Tunisia. You can go there, but it's more and more difficult, because in Tunisia, unfortunately, like in Egypt, you have a lot of politics troubles, and it could be of this problem. And they try to put this stage boundary. We have seen that. I don't want to go in details, but you can see that a lot of these stages have golden spike, have a definition. And now the question is, here, do we add or do we replace the Holocene by an Anthropocene stage? So you have some perfect boundary stage, like the Maastrichtian Dainian boundary, or Cretaceous Paleogene boundary, if you want. The PTM, as you've seen this morning, is perfect. And, well, we will talk about the Holocene in a few minutes. Okay, so it means that you need some good definition. And what to put here now? What to put for the Anthropocene? You have to do it, you have not to do it. This is more or less discussion of this afternoon. Okay, so it means that if we are doing that, it's because we, as I said, the past is a key for the future. The future is a key for the past. I am just here paraphrasing Lyle, meaning that to learn from the lesson from the past, as we learn for example, the KT boundary here, where you have, it's not here, but it has to be here, the meteorite impact, the huge Deccan activity, and this poor dinosaur which are disappearing. Or the PTM here that we have seen this morning. We have to more or less apply the rules that we have seen here to more or less the Anthropocene time. But it's a lot more complicated for a lot of reasons that I will detail later on. But this is more or less a concept here. Okay. That's why I think that stratigrapher, geologist, you are, and you will be very useful in the future, because you know more or less, you take the lessons from that, and maybe you can prevent or at least understand the future change. Okay. So geology is really in the middle of this problem. Okay, now we have to be modest doing this comparison, because there is a lot of limitation when we do this comparison. And here, this is a main question. The PTM that we have seen this morning, is this really an analog of the actual warming, or, to be simple, an analog to the Anthropocene? Okay, so, well, in terms of eating, there is a warming. The warming is quite important for the PTM. Here also, the underlying causes are clearly natural: permafrost, peat, coal fire, methane release, volcanoes. We have seen this morning. Fossil fuel burning, for sure. And environmental change, deep sea acidification. And here there is a lot of environmental change that we may detail later on. And life response. Well, you have diversification, migration, foramnifera, land mammals migration, extinction of some deep benthic foramnifera. And here's the life response. Well, we'll go in details on that too. But the question is not there. You can compare the thing, but you have to be aware of that things, which is really important. Okay, here you see the time, the duration, 10,000 years, 20,000 years. Here we see the temperature increase, change, and you can see here this is just the rate of warming, and you can see that the PTM, even if geologically was very fast, this is still a lot slower than the actual warming. And if you compare more or less the quantity of carbon that we are releasing by year during the PTM and during more or less the actual warming, you can clearly see that it's very difficult to compare them. It means that this is an ultra fast process, and this is the main difficulty that we have, us geologists, especially to explain to the people. Okay, you can compare something, a few things, but the speed of the process, the tempo and the timing of the process is clearly not the same. And this is the main problem when you want to compare. And we published a paper, I don't remember, it was probably 2 years ago, where we tried to make some comparison between the KT boundary, the PTM, and the actual warming. Let's say that it's the Anthropocene mass extinction. And so here we try, this was an exercise clearly, but well, the age of the mass extinction, ongoing predicted. This is a pessimistic way to see things clearly. But the faunal turnover is here, and clearly you have ongoing extinction. For the PTM, it's more origination than extinction. For the KT, clearly it's a mass extinction. So the mass extinction, I will show you after, is in progress. The rate of extinction is really accelerated by now, but well, again, it's a question of tempo and timing. And here there is quite a lot of comparison. Recovery, we cannot really talk about recovery because, well, we are not in a mass extinction by now, but it was quite rapid after the PTM, a little bit slower after the KT. This was a gradual warming, a very rapid warming. Let's say, let's face it, it was really, really rapid, okay? The warming rate is, well, also difficult to compare. And the duration also, well, by now it's decades to 100,000 years for in the future. And the tipping point temperature where everything will change, you can see here this is 5, and here this is 4. And I will go back to that at the end. This discussion about this 4-degree increase is very important. Sea level is really rapidly increasing. 1 or 2 meters, maybe more, it depends a little bit. Acidification is ongoing, and it's a big problem because it means that the ocean recovery will be not so efficient. The biological pump will be not so efficient, so ocean is not anymore regulating more or less the Earth, if you want. And, well, there is no volcanism, clearly. There was volcanism in both of these things. So this is a try. I don't think that everything is true, but we were trying to compare these two things. And you can see that there is some analog, and the main analog is clearly the natural greenhouse effect, which is enhanced by human activity, as you can see here on the right side of this slide. And this is the main problem. And this is clearly fast. And the main question for a geologist, if you want to compare more or less what we're doing now, is do we really go back to the past temperature, for example, to the Cretaceous? And here I just want to show you an example how we can really more or less try to answer to that question, which is a good question, because if we are really going back to the Cretaceous, I can tell you this is super fast. Okay, and for that you have to measure the atmospheric CO2 content in the past 500,000 years, and it's quite easy to do that because you can use ice core, and there is two places, Greenland here and Greenland here and Antarctica here, where you have ice core, meaning that you drill to thousands of meters of ice, and well, you have a stratigraphy if you want. But the good thing is that in this ice, in some of them at least, this is an example of an ice core, you have this small bubble here, and this small bubble have CO2 content. So you can measure the variation of the CO2 since at least by now, I think they reached 1 million years ago, but especially the last 100,000 years are more interesting. So you can measure more or less the fluctuation of the CO2 into the atmosphere by this way, okay? And that's why a lot of people want also to use the ice core in the Anthropocene in order to fix the Anthropocene, but I'm quite against that, because a GSSP in ice, if you melt all the ice, will not last very long. And now, this graphics is really important, because you can see here that you have against the age, this is you have more or less the actual timing here, and this is almost 500,000 here. This is proportion of CO2 into the atmosphere measured in the high score. And here you can learn a lot, but what you can learn, it's a little bit, let's say, very pessimistic, because what you can see here is quite clear. These are the period, or you have glaciation, deglaciation, okay? And you can see here that, well, you increase of 100 ppm, which is a lot less than what we are doing now, very quickly. It's a few thousand of years. But after, in order to go back to the mean values, it takes it takes really a long time. As you can see, there is a huge increase, and here, question is maybe methane hydrate release as a PTM has something to do with this very sharp increase in CO2 into the atmosphere, but the decrease is take a awful long time. So increase, you can see, is 10 ppm by 1,000 years. To go back to the normality is 1 ppm by 1,000 of years. So it means that now it's almost impossible to go back to a normal values. You can probably have a limitation of the increase, but to go back to normal value would mean 1,000 and 1,000 of years. And this is what we learn from the ice core. And this is quite puzzling, I would say. And now if you want to compare that, it's because you can always compare these things. If we do the normal business as we are doing with the actual warming, producing CO2 emission more or less as we are doing business actually. So it's more or less, I put again this curve here, and what I put here here's the proportion of CO2, okay, into the atmosphere. And this is the proportion before the industrial revolution, okay. And here this is the Hansen limit. Hansen is a physicist who said that above more or less 350 ppm, and this is a boundary that we crossed a long time ago, to go back to the mean normal values would be very difficult. But anyway, now if you do a projection, this is where we are today, okay? It's a little bit more, it's 415 okay, ppmv CO2 into the atmosphere. And this is where if we go on with the normal business, it is where we will be in 2060. So 2060, I think, well, everybody here, especially here I don't know, but we'll see it, okay? You are young. So this is really an actual problem, okay? So at least your children will see it, okay? So it means that it's high, and if we go up with that, well, in quite a long time ago, at least I will be not there to see it. In 2160 years, you will triple this CO2 proportion. That's why the problem is the following. So this perturbation is occurring at a rate which is 200 times faster than any increase in CO2 in the last 65 million years. So if you want a comparison, but please don't do it, just take a succession of glacial cycles, okay? And okay, now it means that Pliocene were under the ice. But you always start, and this is very interesting, and you will understand why a little bit later on. It's always the case when you get a cooling in the history of the Earth, generally. I am not talking about the snowball. I am talking more or less in the history of the Earth since 500 million years ago. You always start to put ice on Antarctica and after Antarctica. You know why? You know why you always start to have glacial on Antarctica, and it's only after if the cooling is going on? Because Antarctica is a continent, and it's a lot more easy if you are cool condition, cold condition, to form ice on a continent than to form ice on sea, like it's the case in Arctica. Arctica is not a continent at all. This is just a pure sea. Greenland is clearly a land, but also the ice sea is something different. Okay, so now on that graph, what we put is P CO2, the age. And here, the age are a bit different. If you go from 0 to almost the Jurassic, the Cretaceous is somewhere here. And this is quite a very scattered diagram because we put every way to measure the past temperature, okay? But what you have to recognize here, this is this yellow things, which is the modeling, and there's different kind of modeling. And just take this curve here, and you can see here that, well, the increase of PSO2, which is linked to increased temperature during this time, and the Cretaceous is somewhere here. And now I put the limits. This was Industrial Revolution, 1750, the starting point of the acceleration of the CO2 emission. And now it's 2008. I can put, if you want, also the 2019 would be a little bit higher up. And here you can see that, okay, we don't, in 2008, there is no way to return to the Cretaceous time. But 2060, clearly, we are very close to the temperature of the lower tertiary, the Paleocene, and 2160, we are back to the Cretaceous time. But, well, The Cretaceous time, it was 66 million years ago. And here we are back to the same temperature in, well, a little bit more than 100 years. This is clearly puzzling. Okay, and well, if I am going back, or back, clearly it will worst afterwards. Okay, so it means here that if we burn all the petroleum, natural gas, and coal that we have, we will get this kind of curve, okay? Meaning that I put here some events in history. So this is more or less average annual temperature that you can put here. The human civilization is starting somewhere here. And you can see that clearly there is some warming, cooling period. But there is a huge, huge increase in temperature here, which is linked to the CO2, as you have seen. And this will lead to several problems. And the first problems, which is quite clear, this is the fact that we are melting the ice sheets to the south and to the north. And you have to think the quantity of energy which is required to melt 1 meter of sea ice that has disappeared would eat a layer of water of 1 meter thick from 0 to 80 grades. This is a huge consumption of energy. But you can see here that we are really melting very, very quickly this ice. This is here the years is 1980. And here this is 2007, okay? So this is really fast. And you have an acceleration. And people know that because it's quite clear that in 10 years it would be possible to cross the North Pole by boat during summer, because there will no more ice during summer. And that's why all this area has been extensively explored for petroleum investigation, which is for me not a very good idea, because it means that we will accelerate again the phenomenon. So, and there is a lot of correlative phenomena. And at least, I don't know about India, but in Switzerland we start to have huge problems. And the problems is the fact that you will have a modification of the landscape. And the forest, for example, are really problematic. The forests are disappearing, are drying out. And when the wood is dry, all this nice guy will eat the wood. And insect will be really a predator for the forest in the future. And for example, in Switzerland, to my place, this year has been catastrophic. In some of the forests, this is a change, clearly, because we have a lot less water than before, meaning that since 20 years, in my place, we have a deficit in water, which is huge, even if we have some lakes, very big lakes, and this is fortunate for the drinking water, clearly. But for all the vegetation, we just see a change. And this year, 25% of the trees were drying out. 25%, meaning that these trees are dead and dangerous at the first glance, for sure, because they are just falling down. And they will be replaced by some trees which are more tolerant to dry condition. It's a question of the depth of the roots in order to get the water, but it will take time. It's again the same problem. It will take a lot of time, and this would accelerate also the process. So it means that the melting of the ice can be really catastrophic. Here, for example, one things which will really occur, this and occurring now, this is the release of methane trapped by permafrost. You know that permafrost is in fact all the soils and sometimes rocks or the sediments which is unconsolidated, superficial sediments, are under icy state in the Alps, in Himalaya, for example, is exactly the same. And in Siberia, huge quantity. And in Siberia, well, the upper part of the soils are completely icy. That's why you can find nice fossils of mammoths, completely well preserved with everything, soft part, hard part. But these soils contain a lot of methane and under icy state. And actually, this methane is starting to melt and will be rapidly released to the atmosphere. And methane and CO2 are really catastrophic gas, greenhouse gas. And we can also have, we have seen that for sure, you have more CO2 into the atmosphere. And also, I have to say that industries are releasing a lot of sulfur dioxide in the atmosphere. So you will acidify the ocean. And here you will probably provoke the die-off of the planktonic, foraminifera, and benthic, and the nanofossils. All the microplankton, which are really efficient to do sequestration of the carbon by burial into the sediments where building the shells are not efficient at all, and due to acidification. So this is also a big problem, because it means that the ocean will not so be efficient to regulate the CO2 level as it did from the past. Remember this morning I showed you the example of the PETM, where it was more or less a plankton. We put an end to this increasing warming by sequestrating the carbon into segments. So it means that you have an intensification of this famous negative feedback as I was talking. We accelerate the phenomena and accelerate the phenomena, okay? And this is due mainly to, for example, the decline in Arctic sea level, sea ice cover. And here you can see that, well, this is what we had. We are a little bit here. So up to 2007, this was fast, but let's say still a bit gradual. But here, this is really, really, really fast. And Switzerland is witnessing this change. Like the same, you have exactly the same problem in India, because you have the Himalaya. And this view here show you more or less the evolution of glacial, which is very well known. This is the Rhone glacial. And the Rhone glacial give rise to a huge river going from Switzerland to France and ending in the Mediterranean. Well, you can see that in the 1850, this was a bleak glacial, and the 19, a little bit less. But by now, look, this glacial was arriving here, somewhere here. And now if you want to see the glacial, you have to go up to here. And so it means that for us in Switzerland, we have a serious problem, because you know that, well, Switzerland is very well known for is a tourism economy, ski resort, and we have less and less snow. And, well, in 30 years, if we are going on like that, there is probably no more glacial in Switzerland. All the Alps will be quite black. So this is also quite puzzling, because economically, it will change a lot of things, okay? Oh, sorry. Okay, now if we just go back to the problem of this decline of ice, which will accelerate for sure all the process here, there is something which actually is more puzzling. And here it's just taken from a talk from Bill A, which is a geologist, but also a super climatologist. And Bill Hay, just, you know, you have to go to ResearchGate and find him, because he wrote a book which is really good. It's how to preserve a sustaining planet, and how to preserve the Earth, if you want. And what he did is he put on ResearchGate a lot of PPT presentation in a lot of topics which has something to do with the Anthropocene and the actual warming. And really, I encourage you to go to ResearchGate and to upload this PPT presentation, which correspond to a book, which are really very well done. And what he see recently, 2016 and 2017, something which is never happened before, since that we have more or less this kind of paleography, that's to say South Pole and North Pole to high latitude, that's to say since many millions of years. And the change here are very exceptional. And this suggests that the climate system that we have now has jumped to a new state. So I will explain you that. Here, this is more or less the Arctic. So you have the Alaska, Canada here. The Arctic regrowth in 2016 and 17 is really at a minimum, meaning that you melt the ice, but after it's impossible to regrow the ice at the same level than before. And this is the northern hemisphere winter, meaning that during the winter, well, you produce ice, but you cannot really reproduce ice at the same quantity as before. And this is clearly the case here when you see more or less the Arctic ice extent. This is the area of ocean with at least 15% sea ice. And the blue curve is the last curve. And you can see here, but during this winter, this Arctic ice extent is really at a minimum, as you can see here, and marked by plateau of really cessation of growth. It means that during winter, in Antarctica, in the North Pole, there was some period where it was too warm and there was no regrowth of the earth, of the ice. Now let's go to Antarctic, and here you can see the sea ice melting and a new maximum during the southern hemisphere summer, meaning that here we are melting the ice. And you can see on that curve, this is again the blue curve, sea ice melting during the summer is at a new maximum here, okay? So it's really very puzzling, because for the first time, we have, s'il vous plaît, we have for the first time a coupling of Antarctica and Arctica, meaning that for the first time the two poles are losing ice in the same time, okay? And this is a completely different of the state that we have seen before, where Antarctica was always beginning to get ice after Arctica, and always the first after to lose the ice. So there is a perfect coupling of the two ice caps. So this is puzzling, because the way to produce ice is completely different in the two hemispheres. First of all, in Arctica, sea ice forms in the low salinity ice factory of the eastern Siberian shelf, meaning that you have rivering inflow which freshens the water, the seawater, and which will promote the formation of ice, meaning that this is the climate on Siberia which is really driving ice formation in Arctica. Whereas in Antarctica, which is a continent, this is quite different. Sea ice results for snowfall. This is not the riverine input from Siberia, contrary, and it creates minute low salinity water parcels on the ocean surface. And the moisture for the snow comes from the subtropical South Pacific. It means here that this is coming for the snowfall. And here it means that for the first time on the Earth history, at least since millions of years, since you have these two ice caps, we have a perfect coupling of the ice melting. So, well, these things is happening at a moment which is really not the right time, because it's happening at the moment where we have this huge warming. So this will probably accelerate these things. And you can see that it will change a lot of things on Earth. This is in French, but it doesn't matter. You can understand that. This is a fluctuation of the sea level. And in 2100, if we mean that the Arctica first will completely melt, followed by Antarctica, you have probably at least 2 meters high sea level, and this would clearly change completely the geography of the world. And I'm starting first by Europe. So you can see here, this is a new place where you will have high sea level, and the main of the very nice town like London, Amsterdam, Venice. Here's my, okay. Meaning that Istanbul, Alexandria, Tripoli, all this town will be in water, if not underwater. And well, in Europe, main part of people are living in this town. But where it's really worst, and you are clearly concerned here, if you look to more or less East Asia and India, it means that Mumbai, Kolkata, for example, a lot of Chennai, a lot of town where main part of the population is concentrated will disappear underwater. And you have the same here. Look, this is, for example, Shanghai. You have Beijing, Hong Kong, Ho Chi Minh City, all this town where you have at least billion peoples will disappear. And this will change completely the politics also. And we have to be ready to that, because what does it mean? It means that you will have a migration. It means that for you in India, a lot of people from Mumbai or Kolkata want to migrate and live, for example, in Amravati, because, well, it will be not under the flow. But we have to think about that, because, look, this is 2100. This is very close. And so all this change are linked with this actual warming. Okay, so it's we have to ask from the tea. I will stop here for 10 minutes, 5 minutes, the time of the tea, because now we will discuss a little bit in details, more or less, the discussion about the placement of the Anthropocene. So tea time. Okay. It would have been better to break here, but anyway. No, but no problem. No, I will go on. So you will be free a little bit before. So now the question is, well, how to define and where to put the Anthropocene. Definition of the Anthropocene would be an epoch. And here you can see the two possible things that you can do. Is to put the Anthropocene epoch above the Holocene epoch, okay? This would be a solution where we have to discuss that. After, here, another proposition, this is proposition B, this Anthropocene epoch following directly the Pleistocene epoch. So it means here that, well, the Quaternary before, you know, was divided, as you can see, in Pleistocene and Holocene. And here you keep this division with some substage and stage. But here you more or less put away the Holocene as an epoch and transform the Holocene as a stage and put the Anthropocene epoch on top here. So, well, I think that both of them are not really good decision, but we can discuss this now. Okay, what is more or less the definition of the Holocene? The definition of the Holocene is a bit strange to me, because I don't think that it's a really nice definition. You can see here, first of all, the GSSP is an ice core, okay? And it corresponds to the end of a cold period, which is reflected by a shift in hydrogen isotopes. Well, maybe, but I think it's not a very good definition for the base of the Holocene, but it's like that. This has been ratified by the Commission for Stratigraphy. So, in fact, the first things, you have an ice core, which is a global stratigraphic section. I don't like this, because to preserve this ice core, you can always preserve an ice core in a fridge, but on an outcrop, it will be difficult if you don't have any more ice caps in 1,000 years. Okay. This shift in deuterium more or less mean, I don't want to go in details, but that you have a change, a reorganization of northern hemisphere atmospheric circulation, leading to the end of a cool period and leading to a warming. And here, if you put the Holocene is at exactly 1160 and 650 years old. It corresponds to an increase in temperature and an increase here in red in CO2. But it's not, to me, it's not very clear. Anyway, after there is several propositions about the placement of the Anthropocene. And I think it's very nice to go in details in this kind of proposal, because it reflects really the last events that we got on Earth history, which are really influenced by man. The first one, Holocene, no. But here, the first one to have been proposed is the early anthropogenic methane stage. Sorry for the fact that this curve in color are very difficult to read in your book, but it's quite easy. Here, in green, this is the methane, okay? In blue, this is the temperature, okay? And in red, this is the CO2. And you can see here that this GSSP, this is the early anthropogenic methane. What is this? It suggests that early extensive farming impact caused global environmental change defined by the reflection of the lowest level of atmospheric methane from the ice core, and after this methane will increase. This is that things that you have here, okay, around 5,000 years, that you start here to have an increase in methane because you increase the rice production, for example. You know that rice is not good for the environment, in fact, because it produces a lot of methane, which is a greenhouse gas. And the cattle also is producing a lot of methane. And it's exactly what the people wanted to express here with the beginning of the farming activity, which may lead to increasing methane, but also lead to increasing CO2, because when you do that, you have a deforestation. So the agriculture is not good in that sense, that you more or less erase the forest, which is a producer of the oxygen, okay? So this is more or less a tipping point where you start to do that. But there is a problem here. Farming activity starts not at the same place at the same time. There is some place where farming activity were very early. If you go, for example, in Mesopotamia or Egypt, and some place where it starts very, very late. So there is what we call in stratigraphy a diachronism of the event. And I think it's not really probably a good choice. We have to take tea now. It's on the way. Because after, well, it will be too late. Okay. Now, the second choice that you have read in this paper, this is this name, Orbis, meaning all over the Earth. It's a GSSP which is quite interesting. And to me, this is a good proposal. If we have to find him, it's not so bad. What is this? This is not too complicated to understand. This is the years is 1610. What happened in 1610? This is just the fact that people, well before, were discovering the new world. What is the new world? This is USA, Canada, Central America, South America. And you have really an increase of the connection, of the interchange in terms of economy also between the new and the ancient world. The ancient world is Europe, for example. And you know what happens during this time? In fact, all the people coming from Europe were arriving in Central, South, and North America, but they arrived also with all kinds of various illness, and they propagate this illness and virus to the local population. And a lot of Indians in America, millions of them in South America, were dying. And what happens? All these people, in fact, were farmers. And so they were more or less working their field. And suddenly, this field stopped to be worked and have been replaced by forest. Okay? So it means that this is an inflection here of the CO2 is representing a period where there was more forest because there was no more farming activity because the farmers were almost dead due to all this exportation of illness. But I can tell you, this corresponds to millions of dead people. And all this has been brought by the colony of Europe. So this is this inflection of the red curve here. You can see. And I think there is here an interesting thing, because if you mixed people from Europe with USA, Central America, India, China, and so on, with a lot of commercial interaction, it means that, for example, I just take the example of the potatoes. Potatoes is typical from South America. And after, the potatoes have been exported in Europe and planted in Europe. So if you have you are palynologist, there is a period before where you don't find any palynomorph, any pollen, in fact, of the potato plant. But after this date, you find it in Europe. On the contrary, you will find some plants in South America that didn't exist before. So that's why we call this the great homogenization. You mixed everything. And here you have a paleontological record, in fact. If you look the pollen in a lake, because, well, it corresponds to quite a huge sedimentation here, because it corresponds to at least 500 years, which is quite a lot. You can do a palynological studies and see when you see more or less this mixing between, for example, different plants. And I think it's a very nice way to fix a period for the Anthropocene, if we agree for that, clearly. I don't agree, but I would put it, if I have to put it here, I think it's a good example. And politically, it's also a nice example because it's really the time where, let's say, the colonization were starting a little bit everywhere. So, I think it's time to have tea. Is not here? Oh my goodness. Okay. No tea time today. Okay, let's go to the last one. The last proposal. If you have read that paper, you have seen that they want to use more or less this year that you have here, 1964. To what correspond to this 1964 year? This was, you know, that, after the Second War, at the Second War in Japan, there was the first use of the atomic bomb. And since this time, clearly, this was the time of what we call the Cold War. That's to say that a lot of very powerful land, like US, Russia essentially, but after it was England, after France, India, China, Pakistan, and so on, were more or less having these lethal weapons, the atomic bombs. And before 64, all these bombs, all these atoms, because you have to do clearly some try in order to see if these bombs are working. And for example, in US, they did all this try outside in Arizona, and it was really completely crazy because they put some soldiers in order to see these bombings at less than 50 kilometers of the explosion. It's crazy. All these people die from cancer, clearly. Russian did still better in the stupidity. It's not so stupid, but I think this was really terrible. What they did, they were more or less exploding these bombs in Kazakhstan, close to village, without saying nothing to the people, just in order to check how many people will die or not. So this was the time where all this explosion has been done outside. The French, the English, and so on. And what happens, it was clear that it was a source of pollution. It was quite complicated, quite dangerous. So they decided to sign a ban saying, okay, we will do all this explosion inside, in tunnel and so on, like you're also doing in India, in Pakistan, and so on, in Russia. So a lot of this land, powerful land, were signing in 64, especially Russia, England, and US, a ban of this use of this atomic bomb attempt outside. And okay, that's fine. So, but the problem, they had a lot of try to do, you know, because they have a lot of things of bombs to use. So what they did a lot of exercise attempts before the 64 ban date. And we can see that, oh, tea, come, no, it's not a tea, oh. No, I'm joking. So here, this is 64, you know, is, you can see here that you have a huge increase of the delta C14 that is very present in radionuclide, but there is some other product from this atomic bombing, like the cesium, like the plutonium, and all these peaks in 64 here. You know why? Because the US say, oh, it will be forbidden in 1 year. We have to explode all the reserve that we have. And it's quite nice to see if you look to the temperature here curve. This is a blue curve. That before 66, there was so many atomic bombs exploding into the atmosphere as attempts. It was exercise, clearly, that it provoked dust, and the dust was more or less so dense that the radiation were less, and we have this plateau, this short cooling plateau, which is probably due to the presence of so many dust in the atmosphere following this explosion, but well, it's slowing the warming. But it's interesting to see that we don't have to do that in order to slow the warming, please. We can be tempted to say, okay, if we want a cooling period, just make some explosion, and we have dust here and so on. Okay, I think it's tea time by now. Thank you. So 5 minutes, and after I will go back to that. Okay, I think we have to start because after I really want to have some discussion with you. If we go back to this proposition about the placement of the Anthropocene, so the last one that we discussed here, this is that one, I remember you. This is a bomb GSSP, if you want, characterized by the peak in radiocarbon. And you have seen that these measurements of this delta C14 is made in the 3 rings of wood, okay? So meaning that you cut wood and you have this 3 ring growth, and this is inside that they can count the years, and they found that in 64 there was a maximum of delta C14, 14, sorry, and this you can make this comparison with cesium. This is another radionuclide which is quite enriched when in this more or less atomic things. Plutonium also would show exactly the same. And you can see here, in terms of temperatures, as I said, there is a small plateau, slowing of the increase, which is due to the fact that there was a lot of dust into the atmosphere linked to these bombings, okay, that were more or less very common in US and in Russia, especially during this time. And I will show you after that you will find this increase in radionuclides almost everywhere. Okay, I'll just go back here about the definition about the farming. In that paper, it's also a Nature paper, you can see here that this is a decrease here in more or less the methane, and this concentration of methane has a minimum here, and around, let's say, 5,000 euros, and go and start to increase here. And a lot of people were possibly thinking that this is linked to farming activity, as I said, rice in Asia, for example, here and here in China, in more or less Mesopotamia during this time. But you can see that the different colors here show more or less when start this farming, when was the onset of the farming. So you can see that in India is more than 5,000 years ago, like in China, but in some parts in Africa, this is quite recent, and really in some part, for example, in America, this is super recent. So there is a diachronity of this farming activity. That's why it's probably not a good point to put this boundary where. And after there is, let's say, less formal way to put this boundary. This is to speak about the great acceleration. And here, well, in a formal way, people put that limit in 1950. And you can see here all these graphics are quite interesting because they show, if you take the Earth system trends, for example, and any kind of things which has something to do in acceleration of some systems which are more or less natural systems, show an increase around the 1950. Carbon dioxide, nitrogen, methane, ozone, surface temperature, ocean acidification, marine fish capture, shrimp aquaculture, which is a bit strange to me, but anyway. Tropical forests also have some loss, clearly. It's a loss here. Domesticated land are really increasing and so on. So you can see that since 1950, there is a huge acceleration. And this huge acceleration is can be seen in the Earth system trends, but also in the socio-economic trends. That's really the interaction of man here. Population is dramatically increasing, as you can see here. You can see here the increase in the large dam. We are doing more and more large dams since the 50s, and we are using more and more water. We have really more and more production of any kind of energy. So all these things were occurring around the 1950. But it's not a very precise age as 64 that I just presented you. So on the paper that you have read, you have seen all this proposition to place an Anthropocene GSSP limit. And here, well, this is a discussion of several of these proposals. Megafauna extinction, which occur between 50 and 10,000 years before present, was nearly global, but quite diachronous. I will show you that after. Origin of farming, we talk about that. So extensive farming mainly is diachronous. Rice production leading to this huge methane more or less increase afterwards. Presence of anthropogenic soils due to agriculture. And this one, OBIS, the new old world collision, this great homogenization that I was talking about. Industrial revolution, clearly. This is could be really important. And nuclear weapon detonation, starting in 45 during the Second War, but with these peaks in radionuclides in 64 that you can measure in a tree ring, okay? And after you have persistent industrial chemical, and for example, there is some fluorine gas, but also the plastic, for example. But none of these potential GSSP really fulfills the exact rules of the International Commission for Stratigraphy, because main are diachronous, some are long-term, have a problem with the long-term preservation. How do you preserve radionuclide more than 2 or 5 million years, because they don't last very long. Ice could melt, for example, so if you define GSSP in an ice core, it could be very difficult. They are generally too recent to contain real paleontological markers, as I said, and too local events. And generally, they are not complete on top, because there is not so much sediments above the marker. So it's a problem. But anyway, as a commission for stratigraphy, decided to at least propose some decision. And this decision, well, something has changed since the beginning of the discussion of the Anthropocene. This is the introduction here of some stage. And there is one that you know quite well, the megalion, because megalion is coming from Meghalaya. And so it's a cave. It's a cave near Meghalaya where you have some stalagmite, some concretion of calcite in which you can measure a lot of things, oxygen, CO2, and also get some age. And here, you know that the Holocene, since 2 years, has been divided in 3 stages here. And you know, the last one is the Meghalayan. And you know, it's very short. Huh? It's 42,000 years up to, we don't know, because this is the last stage of the Holocene. And now if you introduce the Anthropocene, you have to introduce the Anthropocene as an epoch here. And the introduction of this stage, in fact, make more difficult the introduction of the Anthropocene. And to me, this has been done on purpose by the International Commission of Stratigraphy in order to slow down this proposal to introduce the Anthropocene as an epoch. But anyway, there is a commission of experts, and this commission make a vote in order to propose a boundary, but it's a proposal which has been after to be agreed by the topmost part of the International Commission for Stratigraphy. And here, look at the voting. It's quite interesting. But this is the vote concern a commission who worked on the Anthropocene. So they are for the Anthropocene, clearly. They are not against them. This is a point here which is important. Is the Anthropocene stratigraphy real? 40 people, almost everybody agree with that. Should the Anthropocene to be formalized? So if you have to put a GSSP, you have to formalize it, and clearly it's a commission in charge of the work, so they say almost all yes. Where to put the Anthropocene in terms of hierarchy? So a lot of them, there was more discussion here, but 20 people over 45 said as an epoch. So to put it here, not as a stage of the Holocene, but as an epoch different from the Holocene, okay? And should the Anthropocene defined by GSSP or GSSA? Meaning GSSP is you have a physical marker. You see a boundary, you have a GSSP, you have a sections. A GSSA is just an absolute age. It can be, for example, the Great Acceleration, and we say it's 1950. They say, no, we want a GSSP, and I think it's a bit stupid because it will complicate rather the things. What is the best marker? And here it's interesting. There's plenty of things, you know, because in the sediments, in the soils, due to human activity, you will increase the aluminium, you will increase the plastic, you will increase the fuel ash particles, and you will find them. You will increase the carbon dioxide concentration, the methane concentration, and you will get some change, isotopic change, and it's interesting things that they choose the plutonium fallout, meaning that this is this famous 64 years where you see this increase in radionuclide that they will choose, because after extinction all these things cannot be really seen. So, well, it means that 64 would be probably the beginning of this Anthropocene, if it's accepted by the International Commission for Stratigraphy. I don't think so. If I know quite well the president, it's a specialist of the Carboniferous, far, far away from the Anthropocene, and is really against the fact to formalize. He is really for using, formal is a term, but to put that, it's very complicated. Here, if you look at 64, there is some sediments above this date. I will show you an example in Switzerland by now, but not so much. And plutonium, the life duration of the plutonium is not so much. So it means that this marker will not last 4 million years. Okay, so this is a problematic here. I will take an example of where to put the Anthropocene in Switzerland, for example, in lakes. Since the introduction of the fertilizant like phosphorus, nitrogen, you have an eutrophisation of the lakes in Switzerland, but not only in Switzerland. You have the same problem in India, everywhere almost, because if you use too much fertilizant, you increase the productivity, and your lake is full of algae, and at the end you get anoxic condition, okay? Like the global anoxic event that I showed you yesterday, for example. And here these are cores from a Swiss lake, for example. Zurich, it's a city in Switzerland, this one, and Lugano, it's a lake which is close to the Italian border. You can see that, you have more and more black colors, meaning organic matter, and a lot of lamination, meaning absence of bioturbation, meaning anoxic condition in some of the lake. And now I want to show you the work that we have done on several lakes from the Jura Mountains, close to my place, with the students. So what we do, we take the students for practical half a year every afternoon, and one afternoon we go to, for example, to these lakes in the Swiss Jura Mountains, and they take core with some boats, small boats, but the cores are very small, it's 1 meter thick, no more, and they take the core back to the labs, and they are measuring any kind of things, mineralogy and so on. Geochemistry has a practical, second years of geochemistry. And they are measuring also clearly the cesium, for example, which is a radionuclide, which is present if you have a bombing or if you have an accident in an atomic producing place like Chernobyl. So lacustrine sediments, for me, would be quite nice GSSP. But the problem that you have to take core, you don't have really outcrops, but it's an easy way to find sediments above 64, for example. And here I just show you an example, which is an example taken from the same lake. The cores is like that. You can see that around 30 centimeters, 20 centimeters, you have a change in colors. More and more organic matter here, very probably. So more or less the biological, the environmental change here are quite important. And what we did, we run some cesium. We are looking for cesium peaks. So cesium peaks, this is the way. This is one radionuclide that you can use in order to find the bomb spike, 64, 63 bomb spike, which is that one. And this one at 86, it's a Chernobyl one. You don't have this spike in India, it's too far away from Chernobyl. But in all the European lake, you have these two spikes. One is linked to the 64 bomb, if you want, attempts. So all these bombs that were exploding more or less around 63, 64, leading to increasing cesium here in the cores. And this one, this is the accident of Chernobyl. So you can put some dates here. So look, you have 10 centimeters of sediments above 64 date. It's not so much for GSSP. And I think this is a little bit too early to think so GSSP like that if you have only 10 centimeters of sediments. Doesn't mean so nothing. But interestingly, 64 or a little bit before, let's say between 20 and the years 20 and 60 here, you have a huge change in the lake. What you look is a change, increasing phosphorus activity, and this will boost the organic carbon because it boosts the productivity, and the organic carbon is linked to the productivity. And here, these two curves are interesting because this one is the input of terrestrial organic matter coming from the continent into the lake as a detrital input, and this is production in situ in the lake, which is clearly linked to the increasing productivity. This is the phytoplanktonic organic matter. And here you have two pictures taken by electronic microscopy, where you can see the base, which is quite clear. These are carbonate, oligotrophic condition. The lake is in good shape, I would say, well oxygenated. And on top here, when it's dark, you can see you change from these photosynthetic animals to diatoms and bacterium. And the change occurs somewhere here. And this will boost the productivity, and the lake is here in danger because it becomes more and more eutrophic, less and less oxygen, and could be completely anoxic at the end. And well, this is the same thing here. It's the only things that we had in these studies. Keys, more or less the nitrogen here, phosphorus, nitrogen. These are two fertilizant components, and you start to inject this into the lake because all around the lake you have field, farm, and so on. And after, well, you increase the TOC and you get this completely transformation of the lake. So in Switzerland, there is different kind of lake. Some of the lake may survive to that because they are more or less oriented parallel to the wind. And during summer, you have a western wind, and during winter, you have more or less an eastern wind. So you mixed very deeply the water during winter. And there is more or less this mix of water, because you change the direction of the dominant wind, is very important because you get an oxidation down to the lake floor. But in some of the lake in the Swiss Alps, for example, and it's probably the case, for example, in some of the lake in Himalaya, they are so deeply inside valley that are not subjected to wind. And here there is not this remobilization of deep water up to the surface and down like that. And for this lake, the situation is more critical. So here the best way is clearly to clean the water before that enter to the lake. It's what we are doing in Switzerland, but this process is very expensive. You have to be a rich land to do that. And it's this eutrophization is really a big problem. It's a threat for the reef. And here you can see on that map that we have really, we are facing a big problem. And this is just only part of the problem. You can see here that apparently the reef, which are, remember, in all the crises that I just show you, the reef was the first to be decimated, to disappear. That's exactly what happened here. And here you have almost 60% of the world reef are to be threatened by human activity, by the warming. 25% are destroyed or severely degraded. And you can see here the Maldives, for example, and this is all this part where you have this very nice reef from Polynesia, Tahiti, and so on. And also the Caribbean, the Red Sea reef, all these one are in danger. And they are very in danger. And you know, again, these are mainly producers of carbonate calcium, which trap more or less part of the CO2 into the rocks, into the sediments. And these reefs are very sensitive to warming, but also to human activity, because close to the reef, if you have a lot of farming, a lot of human activity, you get more fertilizants, so you will get more algae on the reef. They don't like this because the water became more or less very rich in suspension, not very clear, and this prohibits the photosynthesis. So it could be a big problem. And again, this will more or less put in danger all the reef system, this ecosystem, which is very sensitive to change. And actually, what you can see is the formation of dead zone, which are located generally where you have a lot of human activity. And this dead zone, more or less, it's a place where you have less than 2 millimeters of oxygen by liter. And you have this formation of oxygen minimum zone, for example, here, because all the rivers from US were due to intense farming are coming into the Gulf of Mexico, which are so rich in fertilizant that you have dead zone. There is no number here because we don't have this number. It's not because they don't have dead zone, it's because we don't know. And the same here and here. But where we know, where we are measuring these things, the situation is really critical. And this is critical because I remember ocean is the buffer of, is the regulator of the CO2 and consequently of the warming. This is the same slide, so I don't go into details. Now, to end, I just want to put a few words about some details about the Anthropocene. Here, first, the paleontology. Because paleontologists are part also of the debate. Because, well, normally, if you want to define stage, you use paleontology. And here, it's a nice, but to me, well, it's more, well, an hypothesis work that's something really serious because, okay, biostratigraphic zone may establish using abundance zones and mix of native, non-native species, both the marine terrestrial. Okay, but these are very recent. So for the palynology, maybe. But human trace fossil may be also used for marker. Plastic, for example, paved road, for sure, microplastics. But to this comparison, when you compare more or less the early life evolution, remember we speak about that, about Ediacara, about the explosion of the Cambrian, with the explosion of the Anthropocene, where, for example, we have in the Holocene the earliest town, the earliest unified states in Mesopotamia, the earliest big cities, the earliest underground, the metro, the mega city, the great acceleration. Compared to that, I think it's a bit exaggerated, because here it takes millions of years, and here it takes 10 of years, and preservation of all these signals are probably not very good. So this is just a comparison of trace fossils from the Burgess Shale with this very bad guy Anomaluricaris trying to hit some trilobite, and clearly there is some bioturbation, and you can maybe use this kind of bioturbation. These are human bioturbation, for example. But, well, again, the comparison is a bit, to me, difficult. And now, I want to finish this talk about mass extinction, and about talking about maybe next mass extinction. And here, this is, I want first to talk about the large mammal extinction, because this would be the first time for the large mammals where humans are maybe responsible for their disappearance, for their extinction, due to the over-hunting, for example, of the mammoth. These animals were really big and very well known. There is a lot of cartoons. This is Ice Age, okay? And you recognize here some extinct animal like the mammoths here, but also the Smilodon here. These guys probably never lived in the Ice Age. They are a little bit more for the cartoon, but there was plenty of animals like these ones during the last Ice Age, which were quite abundant, like this giant deer, this woody rhinoceros, this saber-toothed tiger, the Smilodon, which is well known, and this cave bear, this horses. And here it seems that the phase of this large mammal occurred at the end of the Pleistocene, and it's linked to the collapse of the one ecology, the steppe tundra environment, but these things are largely diachronous, okay? So it means that here this is probably due in one way to the fact that you jump from an ice age to some conditions which are warmer. So some of the steppe, for example, tundra, this environment where all these guys were living, are disappearing. But there is also, clearly, for the first time in the Earth history, a huge pressure of this nice family that I present you. This is our family. This is a man family. Starting the evolution, starting some 6-7 million years ago, going up to the arrival of the Homo sapiens. But these guys here, especially this guy, were starting to hunt a lot these animals. And here, this would be the first time that really, in a very, let's say, large way, the men would be responsible for extinction. And I present you here a paper because this is a rather controversial. This is a comparison. This is quite interesting because there is two ways to make disappear this woolly rhinoceros, these mammoths, and so on. This is a stress due to the change from cold to, let's say, warm climate, and the stress to the fact that they were hunted by the humans. And here the comparison is quite interesting because they try to correlate the arrival of these hunters here with the disappearance. And this is the dates of their arrival. And here you can see that there is a color code. The red would be really the cause of the extinction will be linked to human. The blue will be linked to the climate. And, well, brown means that we don't really know. And interestingly, you can see that it's difficult to make really a decision about that. For example, the woolly rhinoceros seems to be more linked to climatic condition because it disappeared a little bit before that there was a huge, more or less, population in Europe here. But in US, it seems quite clear that there is a huge correspondence with more or less the presence of hunters and the disappearance of the mammoth, for example. So it seems that, well, the Pleistocene extinction now support probably the fact that there is an interesting point here behind. It's the extinction is mainly linked to a warming, as has been accelerated, and this warming is clearly natural. This is more or less the change in a glacial cycle. So we are living in an interglacial, and apparently it seems that it's a good opportunity to understand that if you have a warming, it's a stressful causes, but if you had the human pressure, it may lead to mass extinction. And I am almost finished here. You have seen these things. These things is a paper from Barnowski. I show this at the beginning, the introduction, just to show here that, in fact, well, to now, we have since 500 years quite a lot of species disappearing, but not so much. But we are not so far for the quantity of species which are endangered, that's about to disappear, to more or less the rate of a mass extinction, which is here, okay? So, well, it means that we really had to take some effective conservation measures if we don't want to increase this rate of extinction up to a mass extinction level. This is more or less the take-home message here. But it means something which is quite important for the debate about the Anthropocene. Maybe we are very close from the end of the Anthropocene. If we have a mass extinction in which probably human will not survive, it's really important so to define the base of a stage which maybe will not last very long. This is a question. And now, just to finish, just to remind you that, well, the sixth extinction is quite close if we are doing the actual business about the warming, about using the fossil resource, oil and petroleum and so on. I already show you that, but I show you again. This is more or less the temperature, just to explain to you why it's so important to discuss about 2 grade or 4 grade of increasing temperature. A lot of people doesn't understand why there is all this discussion about the fact that we have to limit, try at least to restrain this increase to 2 grade and not 4. And this curve is this is a model. You have a pessimistic scenario here. This is red curve, meaning that we're using all the resources without trying to make an effort to use aeolian, more or less renewable energy, but just using the fossil energy. And this one is a little bit more optimistic. We are somewhere here, and already we have some quite high extinction rate in the mountain amphibian. And now we are here. Now we are here. We are in 2020, and the polar systems are really damaged. And, well, these pictures, for example, explain to you that poor white bears are really almost to live with human in order to have some food, because the natural, more or less, place where they are living are more and more damaged by human, and the food is more and more difficult to find. Okay, so now this is just if we increase this temperature, what will happen? And you can see here that over 2.5, the Amazonian forest will disappear. Probably, we don't know exactly how much, but a lot. And around 3 grades, the coral will disappear. The ecosystem the global ecosystem start really to be affected. And if you increase to more than 3.5, you have a stress for several ecosystems, and you get several extinction of endemic species. And over 4 grades, you have probably a major extinction. 40% of the global ecosystem will be affected. And especially, this is just the warming, but you had also the human pressure, okay? So I think that in order to conclude here about these problems, the proposal of the Anthropocene as formal unit, well, I think it's important politically because it may put attention of all the problems that we get on Earth if we are just going on with the usual business about energy and so on. And it may, I think the important things here, the utility of the Anthropocene is to make the people think, okay? You have to think that maybe what we are doing now is not very good for the Earth. And for that, I think this is a very good point. Another good point for the geologist, I think, that a lot of people actually are talking about geology, are talking about history of life. And before, people don't take care too much about this problem of extinction and so on. But is it really a reason to put a formal base of the Anthropocene? I don't think so. And to me, I would more use an informal term as saying, okay, in the 60s we are in the Anthropocene, but I don't want really to place the boundary or not. And I think we can keep the Holocene as a formal boundary between more or less the Pleistocene and the Holocene. We can stay with that, there is no problem. But this is very important to this. Okay, so I have finished now with this presentation. So, well, what I want to do, but maybe you want to do is fine, you can go here to the voice into this one. If you don't mind. If you don't want to. Okay. And you have read this paper, and first of all, well, I don't know if anybody wants to say something about the paper, and I have an opinion and or question about everything. First of all, and after we can start to maybe discuss a little bit. I don't know, what do you think about well, first this proposal of the Anthropocene? Do you have any comment about that? For you it's important, you don't care? So yeah, micro for this guy. No, just use the micro, please.
If you think regarding geological point of view, the GSSP which is given in the Anthropocene, which is not fitting in the geological GSSP, according to me. And it is totally Anthropocene which is defining in the paper, which is a very short period, and a geological period is very long.
Yeah.
Very long. So this stratotype which they are going to define is a very short period. So rather than fitting it in the geological period, it should be a separate Anthropocene. Anthropocene should be a separate term. It should not included in the geological term. According to me, I think like that.
Yeah, I think
because both he has given two options. Either Holocene should be made as an epoch, or it should make as a stage. But I think Holocene is a formal term. It should be epoch in the in that. But Anthropocene should not be included in the geological term because it is not so far it is not completed.
Yeah, I fully agree with you. First, we don't have any end for that stage. So that and it's a very short. And
whatever he has given in the paper, that is agreed.
Yeah.
Whatever he has given, but it is a very short time.
I agree.
The span is very short.
Mm. So, Now, don't be shy. What do you think? I can ask you a few questions because it's mainly a debate for you. It's not for me. I have my opinion anyway. So, do you have any question first of all? And what do you think about that? So, but don't just yes. So, do you want to? You want to say? Are you sure not? No?
The term is very short, like from the industrial the term is very short for the starting of Anthropocene, like from the Industrial Revolution.
Yeah.
I just want to ask that.
What was your question? Sorry, what was your question?
I was saying that the starting of the Anthropocene
Yeah.
epoch is very short.
Yeah, sure.
Like from Industrial Revolution.
Yes, especially if you start from the Industrial Revolution. This is 1750. But moreover, people want to start in 1964, which is really short. You have seen on a core, on the lake core, and I didn't talk about that, but we made also some investigation in India on lakes in order to try to focus on these 64 years. You can find it, but it's very complicated because cesium in anomalies in Indian Lake, it's a very complicated stratigraphy for several reasons. The first reason that these lakes sometimes are completely drying out. So after when the water is going back, you have quite a lot of reworking. And this may complicate more or less the record, but especially because there is too many attempts from Pakistan, China, and India. And we are sure to have the 64 because the first attempt in India was 70. Do you remember? 73, I think. Right? The first bombing attempt in India is 73, I guess. Yeah. Or 71? Yeah. Yeah. 71, I guess. Because we have I don't have this in my computer, but we have the 64 free the first, which cannot be Indian, cannot be China or Pakistan. It's just too early. So we are sure that we have the 64. So we can put Anthropocene in some Indian lake, for example, but the quantity of sediments above is only 15 centimeters. So you are right when you say that this is a very short period. And the stratigraphy based on radionuclides here is very complicated in India because you have a lot of atoms and you don't have a date for everything. China is, for example, is hidden a lot, all this, more or less, when they were exploding all these things. It's not so easy to know. Another suggestion? Yeah.
Sir, I have got one basic question.
Yeah.
We are talking about history of life and mass extinction.
Yep.
So can we presume that the history of life or evolution of life has been stopped or it is going on? We say that it is going from simple to more complex.
Yes.
And there is now this new
yeah,
era of artificial intelligence and cloning and other things.
You
So
are fully right, yes.
What is your opinion, sir?
I think it's difficult to have an opinion because, for sure, if you see more or less the rate of change, this is just incredible. Just think that I just remember, but you don't know that because you don't have an hand, you have a smartphone almost in your hand. But people are forgetting that when I was starting my studies, we were still using card for the computer. So for each of the action that you want the computer doing, you have a special card you to put in, and these are pile of,
yes.
yeah, exactly. And these things it was not so well, so old. Well, it was in 78 or 75.
Yeah, yeah.
And by now we have all these computers, all these things like that, that we just forget from where we are coming. So the evolution is very fast. And the main question, you are right, we have increasing complexity. And how do we just go on with this complexity is a very difficult
We say that
question.
evolution is a one-way process.
Yes. And
so it must be going on.
it must be.
Precision,
It must be, but
more species will be evolved.
But to what? It's a question, but it's a good question. I fully agree. But maybe also, well, if really the situation is catastrophic, it could be.
I agree. I fully
it
agree.
could be likely that we may go back to more or less something which is less complex. It could be more or less, really the last point of complexity. I don't know. I'm just hoping that not, because we have to be optimistic. But well, sometimes when you see more or less the speed of this change, this is rather complicated.
Thank you.
Yeah, for what?
Hello. Very good afternoon, sir.
Excuse me.
So my question is, in district Buldana from Maharashtra, there is a lunar crater.
Yes.
Okay. So it is formed by meteoric impact or volcanic impact?
I think it's a meteorite. I don't know personally this crater, but it looks to me that
there are lot many evidences, because NASA also they have done the experiments. So it is a meteoric impact.
So sir, there is a debate on that.
Hypervelocity meteorite has fallen in that region around 50,000 years back.
Okay.
Yeah, there is a smaller one also is there. So that is the, as on today, a lot of research is going on, but as on today it is accepted, because you are getting the indications of the meteoritic impact.
So sir, what are the evidences for that?
We have lot many evidences. Yeah, specific mineral. Yeah. Specific minerals which will be found only due to high velocity impact are found in this thing. So that is one of this thing.
Sir, one more simple question to you. What is the difference between R flow and power flow? Because I am very confused about that. It's
Excuse
R
me?
flow and power flow.
between what?
Air flow and power flow. Basaltic flows. So
What?
there are two basaltic flows like air flow and power flow.
Uh,
So what is the main difference between that?
Of what? I didn't understand your question. Sorry, but
In Deccan volcanic province, there are
Yes.
different flows like air flow and power flow. So what is the difference between air flow and
Yeah,
power flow?
I think you have to ask again to this guy. He is knowing a lot better than me.
This is very basic difference.
Yes, sir. Yes.
Paha flow and Pahaho. Pahaho is a compound flow. It has got a compound flow has got different flow units, and at the bottom you have the pipe amygdales, and at the top you have the amygdaloidal horizons. So you have the if you want any further information, I can give it to you. So Pahaho flows is mostly a compound flow, which is made up of different flow units, whereas our flow is mostly a simple flow. It is monotonous sequence. It doesn't have, it cannot be divided into different units, subunits. Whereas Pahaho, actually you have got the different this thing. You have ropey structure and all those kind of indications are there. So I have thousands of pages of information. If you want, I can give it to you.
Okay, sir. Thank you, sir. Thank you. Next one. I hearty thanks to Dr. Aditi, sir, for sharing your knowledge with us. Thank you, sir.
Oh, for what? It was a pleasure. Anyway. So. No.
Sir,
We.
so
Oh, excuse me.
my question is that everyone saying that they are not agreeing with Anthropocene,
Yeah.
but if we see evidences, they shows that CO2 level is going on increasing, and all the indications are toward the extinction, because sea level goes on increasing and CO2 level is also goes on increasing. So I think there is a change in a lot of all these are related to industrial revolution, and all these new discoveries and new inventions, that is industrial revolution produce lot of inventions, and these inventions are also responsible for lot of CO2 emission, and this CO2 emission and all their discoveries by human and innovations by human are also related to that are related to CO2 emissions. So these are activities, they have correlation. All these activities have correlation, and they are going towards the extinction. So is it correct? So
yeah, I think you're fully correct. Actually, this is this very nice example of feedback, negative feedback, where you accelerate all the processes, and all this is clearly linked to CO2 and methane and all this very several greenhouse gas, and not only CO2. And especially the methane coming from the permafrost, for example, is a big problem. These icy soils, for example, that you have in Canada, that you have in Himalaya, that we have in Switzerland, are completely destabilized because methane, the clatrate are more or less melted, okay? And in Switzerland, I think you have the same probably in Himalaya. We have a huge problem because all the more or less rocks, debris from the mountains are more or less under an icy state, and we have a lot of melt in Switzerland, and sometimes it may lead to catastrophic events, and I guess it must be the same for you. But I fully agree with you. There is really an acceleration, and well, why not to put starting point to that acceleration? But here's the problem that if you, let's say, for example, choose a plutonium, so these bombs, if you want, spike, is the name of this would be the name of this boundary. In fact, has nothing to do with the warming or these things like that. It has something to do with human activity, but it's not really directly related to CO2 increase or to warming or to the bleaching of corals, things like that. So that's why I think maybe if you want really to do that, why not to choose just a date and to say, well, it's 64, because we have to choose something. But the reality, as a geologist, it would be quite different, because, well, at least for these 64 years, you have at least a markers. But these markers will not last very long, because the half-life of plutonium, I think it's not even 1 million years. So all these radionuclides are just destroyed after some 1,000 or 100,000 years. It depends a little bit which kind of. Cesium is not very stable too. Okay, so little bit more from that part. So, I have a question. What do you expect from geology? What is your expectation? What do you think? But what do you want to be geologist in order to be busy with this kind of problems, or to do something else, or what? What is more or less your motivation? You don't have motivation. Yeah, do you want to answer?
Sir, I think we need more awareness about mass extinction. As we are human, and we are already behind the reason for extinction of 50% of wildlife, as we know. Sir, what will be the major changes happen if humans will suddenly disappear from the earth?
Oh, this is a good question. Again, well, these are not very easy questions. Frankly, I don't know. Well, probably, I'm not so sure that human will disappear first suddenly. Some may survive. It depends really about the scale we are talking on. And by now, it's really a problem for sure. There is too many people on Earth. That's for sure. But this number may be limited quite soon because if more or less you have a stressful environment, clearly not everybody will survive to that. But I'm not so sure that everybody will got extinct. But to say what will be the next, it's a very difficult question.
Sir, as we've seen in many science fiction based movies like 2012 and there are many movies that they shown sudden disappearing or extinction of human beings.
Yeah.
What are your views about it?
Yeah, so sudden, I don't think so. You know, this kind of movie like The Day After, when, well, it's very nice because The Day After, clearly you have some scientists behind that, behind this scenario. They clearly did something which is probably in terms of process very right, because it came from an idea that, well, if you have a cold period, the Gulf Stream you will have a deviation of the Gulf Stream towards Central Africa, Sahara. That's why during the last glacial, Sahara was completely green, in fact, because this deviation of the current may accelerate the production of ice on high latitude. But the problem with that movie that it happens in one day. And this is just not possible. So sometime, well, for the need of the scenario, they are exaggerating the scenario. But behind that, there is something which is quite correct, I would say. Just it takes thousands of years. But by now, I agree with your question, but your question is a bit difficult. I don't think that human will get extinct in 5 minutes. It's not the question, but we are facing some problem for sure. And maybe if we are able really to restrain a little bit and to draw down our more or less emission, it could be likely that more people may survive. Because what I see since 10 years or 5 years maybe, there is a real change, especially with the young, with you. People are more and more aware that maybe we have to be a little bit more careful about what we are doing. But it will take some time, for sure.
I hope so, sir.
Yep.
I have an alternative for current geological timescale, in which we should make 2 stages for Holocene epoch, and out of which the early one is Holocene and the late one is Anthropocene.
Yep.
Holocene epoch have 2 stages, should have 2 stages, early and late. Out of the late one should have the Anthropocene.
Yes, yes. This was this first page. Where, in fact, what you can see here, in the first option, if you look at, they keep the Holocene as an epoch, and they put just the Anthropocene above, okay? And after, in option 2, what they have done is more or less to put the Holocene as a stage, to keep the Pleistocene epoch, and to, in fact, replace the Holocene stage by the Anthropocene epoch. This is what they've done. To me, I think both of them may work, but I think the Holocene as an epoch is quite important because this is beginning really where you have almost everywhere human activity.
Obviously, it's my personal opinion in that the Holocene epoch should have 2 stages, early and late.
No, actually, I can show you this on the presentation. Actually, there is a change here, quite recent, and it concerns India because if we can have the screen again, yeah, please. Okay, I just will go back to that one. Okay. So this is more or less the way that the International Commission of Stratigraphy is looking by now. Well, you can see here that in fact you have the Holocene as an epoch and the Anthropocene as an epoch. And because they do that, because now they divided the Holocene not only in early late, but in early, middle, and late, if you want, with the introduction of this new stage. This is quite recent, 2 years ago. And you have the Greenlandian, the North Griepian. These are really linked to some ice core from Greenland, and for Griep is an ice core name, in fact. And you have the Megalayan, which is the last stage of the Holocene. And well, here they put the Anthropocene somewhere in the 64, very probably. So here you have a free stage for the Holocene. They did this in order really to complicate the things. But this is not the commission of the Anthropocene who did that. This is the commission of stratigraphy who did that in order to to create problem, because here if you do that, you introduced officially stage. It will be difficult to remove again, and if the Anthropocene is here, you have to put a stage, a first stage for the Anthropocene, which will be a bit difficult. And that's why I think, to me, this is a way that the International Commission of Stratigraphy will reject this proposition of formalize the Anthropocene as an epoch, because if you do that, it will be very complicated, because you have to find a stage, an equivalent stage, which would be complicated. Okay, so but I agree. They did it this on purpose. Note that for the Megalayan there is a lot of discussion by now, because a lot of people don't agree with this 42,000 age deduced from the stalagmite, and there is a huge discussion. This has been done very quickly, and this is for me not very good to have done that so quickly, because this introduced a lot of confusion. But for me, it's just a signal that the Anthropocene will be never formalized. But again, to me, this is political, you know. And this is important to propose that, because as you see, a lot of people are thinking about that, and we need to think about all this problem. And the good things for this proposition is it forced people just to think, okay? So that's why I think it's a political reason more than a scientific reason. Another comment? Okay, if not the case, first I will say thank you very much for your attention, because you have been here for 1 week, and I know that it's not so easy to follow this kind of course, because life is very complicated, and to explain history of life is also very, very complicated. But I hope that you learned something, and it was for me very nice to give this course with you. Thank you very much.
Very well, warm good afternoon to all. I, Nikhil Sherekar, start our validation session for short-term course on history of life and mass extinction event by Professor Thierry Adates sir. And also I welcome to both the dignitaries, our course coordinator, Dr. SFR Khadri sir, HOD, Department of Geology, SGBU, and Director IQAC, and our resource person again, Professor Thierry Adates sir. Before start this session, I would like to request from you if anyone want to share your experiences about these 5 days. Anyone? If you want, you can talk in Marathi also.
Very good afternoon to all of you. Good afternoon, sir. So only one thing in my mind about Dr. Thierry Aditi, sir. Your stamina is too good. Your energy is too good. From 14th of October to 18th October, it's a very nice day for me. And one more comment on you. You are a very cool guy. Okay? Obviously. And students are too good from Sant Gadge Baba, Amravati University, Amravati. Thanks a lot to Government Institute of Science, the members of Government Institute of Science, then Sant Gadge Baba, Amravati University, Amravati, and all staff members. Thanks a lot. Thank you, sir.
Anyone?
So good evening, dignitaries on the dais, Professor Khadri sir and Professor Thierry Aditi, and friends. We had been here for 5 days, and certainly we have enjoyed the lectures given by the Professor Thierry. Professor Thierry, I would like to tell you the fact that I was also a firm believer of that fact that the mass extinctions are there, those are due to impact. Now due to while attending your lectures, I came to know that evolution of life, existence of life, and the extinction of life, that is the process that is existing since say from the geological time, that is came into existence, I think. And that is the evolution and the extinction of life, that is I think the two sides of the coin. And that the things are going on, and the things are not occurring at a moment, but those occur on a some time scale. Even the existence of that particular life of a particular species, that is also there for a particular time in terms of your geological scale. So that certainly the lectures were very informative and up to the mark, and whatever the so I am that way. I am from the out. I do not belong to the geology. I belong to the biology or microbiology, and I hope that with the say from your lectures and from your presentations, and also with the help of Professor Khadri, I would be able to initiate some kind of work in this regard, related to some say extinction as well as the evolution of some archaeology, this archaea and bacteria, etc. So that way also I have benefited, and overall the organization was appreciable, and your presence and your sharing of the knowledge with us, that obliged us very much. So certainly I must congratulate to both of you. So congratulations and best wishes.
Anyone else?
Good evening. I am student. I am Ankita Naktode from Sant Gadge Baba, Amravati University, and I know that life extinction and mass extinction is a very broad topic, and it is not ended in 1 week. But those sir try very nicely. Sir explain us very nicely and in very simple language. We had in our MSc we have first sem we have topic in paleontology we had that mass extinction topic, and I had never interested in I am never interested in paleontology, but for me paleontology is very boring subject, and I always thinking that what is the application of this paleontology, why we study study our ancients. But by attending your lecture, my interest, I am very too much interested towards this subject. And recently I completed my MSc, and I am thinking that my research topic should be related to micropaleontology, because it is related to the exploration of petroleum as you told us. And from attending this lecture, I come to know that earth geology and every subject of earth science, paleontology, and all these are correlated, and to become a good earth scientist we should take interest in all of this. So thankful to Dr. Adati sir for upgrading my interest in paleontology, and I'm also thankful to Khadri sir for organizing this wonderful course through GIAN through GIAN. GIAN is very nice scheme, and when we see that on that portal GIAN, all the lectures are most of the lectures are organized by IIT students, IIT institutes. And this is only our Amravati University organized 2 lectures. One is from biotechnology department and one is from our department. So I specially thanks to Khadri sir for organizing this event and give us chance to meet Dr. Theri Adati sir, and thankful to all.
Now I request to our course coordinator, Professor SFR Khadri sir, for few words.
First of all, I would like to thank our Honorable Vice Chancellor, Pro Vice Chancellor and Registrar for making necessary arrangements and permitting us to conduct this program in such a nice atmosphere in the Senate Hall. And then next, I am very much thankful to Terry, because he, within a short notice, he accepted our invitation, and he has taken a lot of trouble, pain coming all over from Switzerland and enlightening our students. So this is a wonderful experience, I feel, and thank you so much for your efforts and other things. And our students certainly will get benefited from that one. And as one of our students saying, they started getting interest in paleontology and micropaleontology. This is a wonderful experience. So, and I am thankful to all the staff members and the students who have participated very nicely, and I never had any much trouble in organizing this thing, because all of you have done very good job. Thank you so much for that one. And I thank everybody for cooperating in this program, and I feel this is one of the grand success, because we could get lot of information which otherwise we could have not got it within a short span of time, because this is such a broad topic. It is very difficult to understand if you don't undertake this kind of course, because he has elaborated very nicely, starting from the the history of life, and then history of the earth and all those kind of things, coming to the Anthropocene and all those things. These are the different things, and there is a debate sort of thing, but we have to, he has drawn our attention towards this one. This itself is a great success. That's what I feel, so that you can start thinking in that direction. Thank you so much for attending this course. And thank you, Terry, for your, once again, thank you so much.
Now I request to our course coordinator, Professor Dr. SFR Khadri sir, to present a gratitude gift to Professor Theri Adati sir as a token of knowledge. Next, I request to our resource person, Theri Adati sir, for a few words.
I think that I speak already too much, but doesn't matter. No, well, first of all, it was a really nice week, and I have a really great pleasure just to give that course. And because I think it's quite important that everybody can more or less have at least the feeling, one feeling of what is more or less this kind of this part of geology, which is not only paleontology. Geology is really at the cross of many science. Paleontology is something, biology and chemistry, geophysics, physics, and so on. And so that's why it makes geology so attractive to me. It forces you to think not just on one way, on one direction, but forces you just to use all the tools coming from different kind of sciences. And this is really the beautiful aspect of geology, because by this way you really you can understand more or less what are really the big processes which are really triggering more or less all the interaction that we have actually in our biosphere. And I think really to take all these lessons from the past is very important, because by this way you can try to be educated to understand a little better what are all the interactions of our world, and just to understand that this is something complicated. This is really the first step, and you cannot simplify more or less Earth and life on Earth to just a few sentences. This is something a lot more complicated, but this is something beautiful, and I like really to transmit this kind of knowledge to the students. And I have to say that you have been really excellent students, very attentive, and I really thank you very much for that. And I thank you also clearly, Syed, because I would not have given this course without him, for sure. He was really behind all this organization. I have thanks also clearly all people like the Vice Chancellor and so on, which are all behind also this organization. And but Syed, I just hope just to go on with our collaboration, to go on with him on the field, because to do field work with Syed, it's also a lot of fun. So it's not boring at all. And I just hope to go back one time to Amrati. Thank you very much.
Thank you, sir. Now we move towards the certificate distribution ceremony. So I request to dignitaries to present the certificate to all participants. First, Mr. Karthik Prahlad Tiwari, please come. Shubham More, Sheikh Akhlaq, Professor Ashok Srivastav, Miss Tanvi Khandekar, Miss Ankita Mude, Miss Sampada Nagpure, Amit Vijay Jaiswal, Ashish Bhavane, Akshay Ghatod, Shivani Watane, Prakash Jha, Professor Nitin Firke sir, Pavan Kumar Giri, Miss Varsha Pawar, Nitesh Chauhan, अविनाश राउत, फ्लाविया मोरे, प्रोफेसर मोहन सोनार सर, रोहित मोरे, मिस रूपाली लोखंडे, मिस मोनिका मानके, अक्षय सवालाखे, प्रोफेसर प्रेमानंद तिड़के सर प्लीज, मयूर शेंडे, अश्विनी राउत, कल्याणी डवरे, शरद ठाकरे, परीक्षित देशमुख, प्रोफेसर यादव कुमार मावड़े सर प्लीज, नंदिनी भूंबर, सुमेध वरघट, इरफान अली, ओके, प्रोफेसर सतीश कुलकर्णी सर, अंकिता नागतोडे, शिवानी धोंगड़े, आकाश करंडे, दीक्षा खरात, अमृता सिंह, भाग्यश्री वावरे, सदानंद कावरे, स्वप्निल गुड़दे,
Now, thank you so much. I declare that our workshop is over. The short-term course is over. Thank you so much.
Thank you, sir.